Okay, this short video is going to go over how to identify the number of the subatomic particles within an atom and how to draw a Bohr model using that information from numbers off the periodic table. So if we start with hydrogen, hydrogen has two numbers in the box. There's 1, which is a whole number, and that whole number is what we call the atomic number. And that equals the number of protons. And I use a P with a plus sign because protons are positively charged. And then the other number is not a whole number, it's a decimal, and we call that the mass number. And it actually equals the number of protons and the number of neutrons. Okay, so the mass number actually tells you how many things there are in the nucleus. Protons and neutrons are located in the nucleus of the atom. The electrons are found outside the nucleus. And for what we're doing right now, the atoms we're dealing with are neutral, so it's going to have the same number of positives and negatives. So whatever you get for the number of protons is what you're going to get for the electrons. All right, so let's pick a different element. How about manganese? Mn. All right, so we're going to do manganese. All right, the numbers within the box for manganese, the whole number is 25. That's your atomic number. Okay, that's the number of protons. So manganese has 25 protons. And then the mass number, which is everything that's in the nucleus, there are 55. We're gonna round that 54.938 up to 55. And so that's how many things are in the nucleus. So to figure out how many neutrons you have, you take the total number of things in the nucleus and subtract the protons from that, since protons and neutrons are in the nucleus. And when you subtract 25 from 55, you get 30. So there are 30 neutrons in a neutral manganese atom. And then electrons are negatively charged. The protons are positive. We have a neutral atom, so we're going to have the same number of electrons as protons, so it's 25. Okay, so that's how you figure out how many protons, neutrons, and electrons you have. All right, let's try another one. All right, let's do chlorine. Okay, chlorine, Cl. All right, the numbers in chlorine's box, we have the whole number 17. That is your atomic number. That is the number of protons. So there are 17 protons. To figure out the neutrons, it's going to be, you take the mass number, 35.453, and we round it to 35. So there are 35 things in the nucleus. To figure out how many of those are neutrons, you subtract the protons from the total number of things, and you get, what is that, 18. So 18 neutrons. And remember, protons are positive, electrons are negative. We have a neutral atom. So there's 17 electrons, same number as the protons. Now, if we want to draw the Bohr model, we have to put the protons and the neutrons in the nucleus. So we have 17 protons and 18 neutrons, and then 17 electrons. Now the electrons are going to go on these orbitals or electron clouds or energy shells. There's lots of words for it. The first one is so small it can only hold 2 electrons on it. So 2 of the 17 are going to go on that first shell. And then you draw another shell. And these can hold up to 8. It's called the octet rule because they can hold up to 8. Okay, so now we have 8 on the second shell, 2 on the first shell. That's a total of 10. We still got to do 7 more. So we're drawing another shell. And we're going to put 7 on it because it can hold up to 8 as well. But we only need 7. So there's our Bohr model of chlorine. We got 17 protons and 18 neutrons in the nucleus. Then we have 17 electrons, 2 on the first shell, 8 on the second shell, and 7 on the third shell. And you can do this with any of the elements on the first 3 periods. That's these top 3 periods. When you get into the 4th period where potassium is, it starts getting a little bit more complex. But that's essentially how you calculate the protons, neutrons, and electrons and draw a Bohr model.